Hello everyone, this is Ming. In this section, we are going to cover software skills and project cycles in data science. We are going to break the section into two videos, and this is video part 1. First, let's look at the difference between statistician and the data scientist. We all know at the universities there are science school and the engineering school, and there are fundamental differences. For example, in science school, we have physics. In engineering school, we have electrical engineering. Those are very different subjects. Basically, the physics is trying to study the fundamental of how electrons work, while electrical engineering is based on the fundamental principles of how electrons behave and try to create devices to help people's daily life. It is the same thing for statistics. The majority of the statistics department are actually in science school. But we do not have a particular statistical engineering school for statistical related applications. And nowadays, with big data and software become available, there's additional requirement for statistical applications to change people's daily life. The whole idea of statistical engineering with big data and software is more or less what a data science subject is about. So as you can see, data science is actually an engineering subject. People are using fundamental principles from statistics machine learning, try to create solutions to help people's daily life or to solve a business problem. And those are the difference between statistician and data scientist. As a statistician, we are relatively focused on modeling. That is basically the science part. For data scientists, primarily focused on business problem result. It's pretty much an engineering type of work. For statistician, we usually bring data to the model. For data scientists, on the other hand, because the data is so large, to move the data around is very expensive. So on the other hand, data scientists usually bring model to the data. For statistician, we're all familiar with small data set. Small here means the data can be fit in one computer's memory, and all the computation can be done using one CPU and one memory. And the data format is relatively clean, tabulated format with numerical values and categorical values. For data scientists, people has to work with pretty messy and large amount of data with all different kind of format, text, image, videos, etc. For statistician, we usually deal with structured data in a tabulated form. For data scientists, it will be both structured and unstructured data. For statistician, usually the data is given to us and we're pretty much isolated from the production environment or system. Data scientists, on the other hand, is usually embedded in the production system. In most cases, the software and the IT infrastructures. So those are the difference between statisticians and a data scientist. So this is basically the skills for a data scientist, for successful data scientist. Of course, modeling knowledge is important, including statistical and machine learning models. And those modeling knowledge has to be equipped with a scripting language, R or Python. In addition to modeling knowledge, there is another essential dimension, which is the production system, knowledge, and programming. Here, programming is, in addition to Python and R scripting language, programming in terms of SQL, Java, and big data platform. Because of the cloud environment and Spark big data infrastructure, the bar for production system knowledge and programming are dramatically reduced in the recent couple years. But again, SQL still remain a needed skill for data scientists. Another dimension is business knowledge and dashboard experience. Business knowledge will be specific for each different team. The dashboard, typically in enterprise environment, it is Tableau, as well as now R-standing become popular. Those are three different kind of dimensions for a successful data scientist. From job function point of view, I call all those a kind of within the umbrella of data and analytics job family, like business analyst, business intelligence engineer, data scientist, research scientist, and applied scientist. People with education in statistics, actually there are different kind of opportunities for different level of education. For example, for bachelor's, master's, and PhDs in statistics, and those are some of the potential job career families. The dashed line is potential. The solid line is more or less preferred. So for a successful data scientist, it seems like to have all three directions requirement to be all good at it. But in reality, it is very difficult for somebody to be good at all three. If you are good at all three, you become a full stack data scientist. A lot of companies, especially startup companies, are hungry for those full stack data scientists. Basically, when they successfully find someone good at all three, then it's kind of like they hire one people and get two more for free. But in reality, data scientist probably is going to be good at two out of those three areas in reality. And each career path has its own promotion cycles. Like business analyst has a very strong focus on business knowledge and dashboard experience, and applied scientist, on the other hand, is towards a modeling implementation in the production environment and the modeling knowledge. There's also a difference between generalist and a specialist. A generalist is primarily most of the data scientists are people in this generalist data scientist career path usually focus on business problems for all different kind of areas and organizations. Data pre-processing skill are essential. Statistical and machine learning method are needed. And nowadays, deep learning applications knowledge become a preferred skill set. For specialists, on the other hand, it is more focused on natural language understanding, image and video, voice, language translation, a specific area where machine learning sometimes is going to approach, reach even beyond a human's capability. Now, let's focus on the data science project cycle. For a end-to-end data science project is always from concept to product. And during the whole process, the big data infrastructure, strong modeling background, and soft skills are essential to ensure a successful data science project. And during the process, data at the end of the day become decision and actions. As a statistician, we are all familiar with modeling stage. During modeling stage, we're focused on model exploring and development, model training, validation, and testing, and model selection. And majority of the machine learning and data science literatures are focused on those. But on the other hand, even before modeling, it is an essential piece of how can we formulate a data science project. How can we quantify the quality and the availability of the data pre-processing and feature engineering are needed even before the modeling piece. It looks like the beginning of the project, but in fact, it is not. For a data science project, even before that, we need to have a business problem at hand first. What is a problem? In most of the cases, that problem is not easy to define. And once we have some sort of business problem definition, then we need to quantify business value and define key metrics. Basically, how can we quantify that a data science project is going to be improving or reducing, and how can we define success? We need to allocate the computation resources, and nowadays, of course, with big data cloud environment, the computation resources are relatively easy to obtain, but again, there are costs associated with that. And how can we put key milestones and timelines to time-bound a data science project? And more recently, data security, privacy, and legal become a very important aspect for any data science-related project. How about after modeling? Is that the end of a data science project? Actually not. If the final model is going to be implemented in production environment, we need to do a A/B testing to make sure the model we developed in the model training stage is going to perform equally well in the production environment. And in most cases, the training data are used offline data, historical data. So the performance in real-time future A/B testing may not be the same level. We could see model degradation, or sometimes the model is not working at all. So A/B testing is actually ensure that we do have a working model in reality. Once we have the A/B testing, we're going to deploy the model in the production. Once the model in the production, we have to keep an eye on exceptions. Like for example, the model has 10 input variables, and suddenly one of the variables in real time become not available, and how the model is going to deal with this exception. And machine learning models is going to degrade over time. We need a performance monitoring system to constantly monitor the performance of the model. And also, we need to have model tuning and retraining if the model performance is degrading. And sometimes we need to update the model and add new features and retrain the model. At the end of the day, eventually, every model is going to fail. And we need to have a retirement plan for the model at hand, as well as for future. So as you can see, a data science project cycle is always from the beginning to the end. There are a lot more than just modeling and data pre-processing. There are a lot of other aspects for a successful implemented data science project. Because data science projects involve so many steps and so many stages, it will need a cross-team collaboration. Like for example, with the business team, we have to know what is the business problem and what are the major pain points and how can we quantify whether a data science project is working or not. Technology team, where the data comes from. the database, data warehouse, cloud infrastructure. We have to work with data engineering team to build up the pipeline. For the project management team to coordinate with everybody. And as a data scientist project, it probably is from the senior leadership's point of view. There are their own ideas and try to incorporate to improve the overall efficiency, not for a particular organization, but for the entire company. So we have to communicate with leaders across different organizations. All those requires a fast, agile style product management and collaboration. Now let's look at it, different kind of data. There are offline data and online data. The offline data is historical data in the data warehouse system. It's usually pretty big and it is pretty slow to retrieve. And it's usually very rich in general. Nowadays, companies is trying to save as much as possible. And it is relatively low cost to maintain in a data warehouse. And those data can be extracted in batch as raw material for features and in turn for model training. But the offline data that we see on the data warehouse usually are from different filters and joined with different tables, and then it is not the same as the online data. Offline data are typically used for like data exploratory, feature engineering, and model development. Online data, on the other hand, is what is the data available in real time for a model to run for real-time decision making. Like, for example, the customer's search keywords, etc. It is very high, relatively high, to maintain with low latency. And usually for the online piece of data, you usually have limited selections for data available for the model. Additional data can be added, make it available online with extra effort. So a typical data science project using machine learning is model trained in batch using offline data, make features using the model available online, and model use online data to make real-time decisions. There are also offline-only model with regular batch process and model training using online real-time data and deploying in real time depending on different applications. So those are different kind of type of models we see. All right, now let's take a break. And on the second video, we are going to continue with the common pitfalls of data science project.